So, welcome everyone to the last lab of the semester. Thanks, Richard, for joining today. It's just you and me here today, so thank you for coming, and I hope everyone else has a chance to catch up on the recording. So, today's lab activity is it's the last lab. Basically, it's an IoT scenario again. Uh, It is somewhat similar to the previous lab that we looked at, and we did a scenario that has a lot of similarities to this one, although this one does use a gateway. But I think that what we'll do is we'll make a little bit of a change to how it goes. What we'll do is we'll do a scenario that's maybe a little bit more complex than what the original lab material is. So if you do the original lab material and submit that, that's okay. But today I will demonstrate something a little bit more complex, just to give you an idea of the kind of simulations that you can run in Cisco Packet Tracer. So we'll look at the environmental simulator today. So I did mention this a couple of times in the earlier labs that Cisco Packet Tracer has quite a complex environmental simulation system behind it, which allows you to simulate all sorts of things that are happening in the environment and how they interact with different IoT devices and how those interact with the network. And so that's sort of the idea of what I was going to do today. So the scenario that's in the lab sheet is basically similar to what we did in the past. It's a essentially a security scenario, a physical security scenario. It has a siren connected to a home gateway, and then there's the motion detector and a camera to capture the images of whoever's getting into the building. So that's sort of the idea, and it's very similar to the one we did in the past. We actually did one of those scenarios about a server room that has a motion detector and a siren in it. So I think, excuse me, the added interesting part of the camera is not so important that we would do the same scenario again. So what we'll do today is we'll modify that scenario to be a fire alarm scenario. So this would be like if you had a server room or perhaps, a lab somewhere in the university where it has a fire alarm and a fire monitor, and it's all centrally controlled from an IoT server. So when something catches fire in the room, the fire monitor detects it. And then there's all sorts of things you can do. You can turn on sprinklers. You could close the doors or open the doors actually to allow an evacuation. And then unlock the doors and close them so that if people need to evacuate, they can leave. Or once the evacuation is complete, you want to close the doors to contain the fire. Uh, and then there's, of course, a siren that we can turn on for an evacuation. So, in order to achieve that scenario, basically what we're going to do is we're going to do the same kind of setup as was planned for the lab. We're going to have a home gateway, but we're going to make it part of a bigger network. We're going to have a server room that has some equipment in it, and then we're going to model a lab room with a fire monitor. And then the next part that we're going to do is we're going to set up a environmental simulation, and we're going to basically make something catch fire in the lab and then see how the IoT devices react. Sound good?
Sounds brilliant. Playing with fire, nothing better.
Yeah. Yeah. Okay. So let me go ahead and share. Okay, can you see that?
Yep.
Okay, good stuff. So let's drop our devices in. I won't get into too much of a lengthy discussion about it because we've already done a couple of these types of networks in the past. So I'll get straight to putting the devices in and setting up the network. So the first thing, let's set up our sort of network diagram here. So we're going to have, we'll call this up here, we'll call it the control room or the server room, I suppose you could call it. We'll call it the control room, has all the equipment in it. And then over here, we'll have another room, which we'll call the lab. Okay, and this is, we're just using this because it's a university, but you could imagine that this is similar to any sort of manufacturing scenario. We have equipment that's running, or a power generation scenario. We have, well, obviously these things give off a lot of heat and have potential for fire, so it's the same kind of idea. So what we'll do then is we'll drop in some network equipment. So we can start off with a router, and let's drop in a switch as well, so that we'll hook up everything in the lab room to this switch. So put that in there. And then we'll have a server, because this is what we're going to need for the IoT registration. So we can drop that in here. And then let's get started with those. And then I might just drop in one more piece of network equipment. Where's that? Looking for wireless devices. And over here, you've got the home gateway. Okay, so home gateway enables us to connect to various Wi-Fi devices, which are IoT devices, and we will need that for the siren. Okay, so let's start hooking everything up. So basically, we'll start off with the switch. Put this on. That'll be 00, and then um, we'll drop the connection there for the server. We'll just connect it straight up, even though obviously this would probably be somewhere in the internet, maybe in a cloud server. Doesn't matter. We understand how that works. And then we'll hook up the home gateway as well. Excuse me. Wait. That's odd. Why can't we connect the home gateway?
It may be that your router's only got gigabit ports and the home
Yeah,
gateway's only got fast Ethernet ports.
that does
So it
sound.
might connect into the switch instead.
Um, I have connected it in the past directly to the
Yeah.
router, so there we go.
Okay. Look
Why
at
did that
that.
work? 00. Okay, whatever. Sometimes you just there's not worth trying to figure out why.
No.
Just these quirks of the simulator. See where we're at. 01. That's okay. We'll remember where everything's hooked up and we'll be okay. Cable cannot be connected to that port. This
You
is
check.
a 2901, doesn't have enough ports. That would be
I
it.
think so. I think that'll be it.
Yeah, that's the.
Yeah.
We'll swap. My mistake. Let's swap that device out and put in a bigger router. That would be the issue. So 2911 router should have 3 ports. Makes sense. So let's hook it up to the switch, hook it up to our server, and hopefully this will work. We'll hook it up to home gateway. Okay, great, great stuff. So yeah, so now we've got these three. I'm just going to put in some IP address labels here. We're just going to do a real simple scenario, not really worried about the network design too much. Let's just say this is 5555 somewhere in the internet. It'll be class A, and then so this whole sort of network side of the router will be at 5550, and then we'll have to give the router an IP address in that subnet so that it can talk to the server. We'll drop it a 5551, call it that. Sounds good. Next thing that we'll put in then will be the switch. So we could just give it another sort of an IP. We'll have to give the router an IP in another subnet. So let's call it 2221. And then down here in the lab room, we'll put everything on this subnet as well. So we'll call it 0 and got 8 there. Um, So that's going to be the wired connection in this room. So this room's got two connections. We've got wired connection through the switch, and we're going to hook up the some of the things to the wired connection. And then there's going to be this gateway over here, which is going to have wireless connection. So that's going to be on its own. It's actually got two subnet, its own two subnets. So I'll show you what I mean by that. So over here, it's got one subnet in its connection to the router. So we could call that, say 666. In this case, it'll be two. We'll give this one 6661. So, I mean, this is really, you could give it all the way up to like a really tight net mask if you wanted, but it doesn't really matter. But, but I mean, this is just basically a point-to-point connection. So you only need really four IP addresses. You need the two endpoints, the network address, and the broadcast. So you could really tighten the net mask on that if you really wanted to, but we're not really concerned too much about that today. So let's have a look inside the home gateway, and I'll share now the screens for the configuration of the gateway. Okay, so you can see we've got our gateway here. The gateway actually has multiple interfaces over here. One of them goes to the internet, another to the LAN, uh, and then the last one is the wireless. So the LAN, this is where we're going to connect our IoT devices to this port via the wireless connection. And so the wireless connection, this part here actually covers the wireless part of connection. So you can see it's got all sorts of interesting things. This comes back to the environmental simulation. You can simulate the coverage range and all sorts of basically all sorts of environmental parameters. We could provide a username password here. We've done that a lot of times in the past, so I'm not going to set that up today. I'm just going to leave it open, but of course, we'll have a chat about that later on. And And so basically we want to just see what the IP address is here. So you can see this is just like your home router. It's going to provide a local network based off of that subnet. So it's just a regular 192.168.25.0 will be the subnet there. And then let's just set up the internet address. So we're going to give it a static IP here, and we'll give it the one that we marked down on our diagram earlier, 6662 with subnet mask. And the other important thing is here is to set up the default gateway, because otherwise we won't be able to communicate, because this has multiple subnets and we need to be able to route through the router. So we'll put 6661. We're not using DNS today. Okay, makes sense.
Yep, all good.
Okay, great. So let's go back to our diagram. So we've now set up the home network. Let's go into the router and configure the router. So our router configuration today, basically we've got three ports. So let's just make sure we remember which one's which. Um, we've got our server on port 1. The switch, which is going to go to the wired network, is on port 0, and the gateway would be port 2. So on the 0 port, we'll just turn that on. We'll give it the address that's in the wired network range we can use in the lab. So we're going to want 2.2.2.1 there. And then on leg number 1, which is the server leg, then we're going to give this port the the IP address in the range of the server, which is in number 5. And then the last one that we want to do, excuse me, is we want to set up the gateway which connects to the wireless devices at 6662. Sorry, 6661. We'll turn that one on. Okay. That's basically it. We're not going to set up DHCP today and all those other things that we've had in the past, because we have done them quite extensively. So we'll do that. Gary, I see that you've just joined us. So I'll just recap where we're at. This lab is the last lab. It's the lab 10 sheet. So basically the scenario there is to set up a physical security. It has a siren and a camera. and it's operated by rules. We actually did a scenario that was quite similar to that in the earlier lab. So what I'll be doing today is we'll do a scenario that's a little bit more complex, and it will basically be a fire alarm scenario, and it's going to show you how to use the environmental simulator in Cisco Packet Tracer. And so we're just powering through that one, setting up the network at the moment, and we'll do that one. Hopefully, we'll have enough time at the end to discuss some of the security implications of what we've done as well. So that's the plan for today, and you can either submit the original lab material as it is. We'll accept that, of course. But if you'd like to do something a little bit more complex, then you can stick around. We're going to be doing the fire alarm. Okay. So let's continue. So we are now. You can see the network there. Is that right?
Yep.
Yep, network. Okay. So our next step is going to be now to hook up the the wired part of the lab here. So we're going to drop in a few devices here. So let's start off by we're just going to drop in a regular PC. This will sort of stand in for all of the different lab equipment that we'd potentially have there, and it'll also enable us to do a bit of pinging and see that everything is up and running. So that's that one. Then we're going to have our IoT devices. So if we look under um, s the smart home tab, there should be, uh, find it, smoke detector. No, it's not the one. We'll go to the smart city. Must be under this tab. Uh, no, hang on. Looking for the fire monitor. Here it is under the industrial tab. Okay, you don't get a fire monitor at home, it seems, or smart city, you got to go in the industrial tab. So we'll put in this little piece of equipment here and we'll give it a name, fire monitor. So this IoT device, basically what it does is it monitors the infrared, like that's given off by a fire. So uh, when it detects that there's a fire, then it's a registered IoT device. It'll flag that there's a fire, and it can um, and you can take some sort of action conditionally based on that. So that's the idea. So let's have a look inside and see what it does. So you can see it detects flames by checking for a property and finding if the IR property value is in the range the detector considers a fire and outputs a signal. So if it's a fire, then it'll go high. And so there's an example here. Create a thing in the script and set a fire property with set device property get name IR 900. So this little line here basically tells us how we're going to do it. And we haven't done this in the past, but there's actually a whole programmatic, like a programmable simulator in that you can program with some JavaScript in the back end of this simulator, which I'll show you in a moment. And we're just going to create a thing. So a thing is an undefined kind of object, and we're going to give it some behavior according to what we want, which is going to be a very simple behavior. It's just going to be the fact that it's on fire. But that's what we're going to do. And it radiates infrared heat like out into the environment. And if you're close enough to the fire monitor, then it will cause the fire monitor to trip, and then you'll be able to conditionally activate something else. So that's the idea. Let's go ahead and configure it. So we're going to give it we're not using the DHCP server here, so we're going to put in a static IP. So firstly, the default gateway we're going to set to 2.2.2.1. That's going to enable it to communicate with the IoT server. Let's give it an IP address as well, 2.2.2. Let's say 10, subnet mask, and we're ready to go. Okay, so from here, it's probably best that we go ahead and set up the the server, because the server has to be registered for IoT devices. So you remember that we have to turn on all of the services. So we're going to go ahead and do that. Um, Down here under IoT, turn on the service, and then we have this thing here. We've got to create an account in the IoT monitor. So our IP address is 5555. That's not going to work, of course. It'll ask us to, hang on, we haven't given it an IP, have we? That would make sense. So let's give it a static IP. Should have done that first. And then we'll put in the default gateway as 5551. Okay, now if we go back, that should work. Try that again. 5555. Create our account. We'll just do an admin account again. Great stuff. Okay, so now our server is set up. We can go back to configuring all of the IoT devices to use that server as the registration server for the IoT service. So I'm just going to go back and share that. So excuse me a moment. Um, okay. So we'll just go home and we'll go here and we'll set it up again. You could set it up as the home gateway as another possibility there, but we want to be able to have this server there. So we're going to go ahead and use the server, admin, and we'll see if we can connect. All right. So let's go and have a look and see if we have got the server to be. Just need to refresh that moment. We should see, if all goes well, we should see our fire monitor. Oh, we won't see the fire monitor, will we? Because we haven't connected it to the network. Excuse me. Um, do you see that network again?
We do.
Right, forgot to connect up the fire monitor. So here we go. So I'm just going to go ahead and hit connect, save time, because we've seen this a lot of times before. And we've got one more device that we want to model here today, which is going to be the smart alarm that's all set off. So this I think is under home, siren. There we go. We'll just drop that in there. This is going to automatically connect to the home gateway. So we just make sure that it has its server IoT server set up. So we've used this one in the past. So I won't go into it in detail. Well, let's give it another IP address. Oops, sorry, we used the DHCP. Yeah, should have connected via DHCP. We should have got a wireless connection, but seems that we do not. Let's try and refresh that. yeah. Back to this thing like last time. We are supposed to get a IP in the 192.168 range. Um, so it's odd that we don't get that.
Is it worth having a look at the config of the home gateway? I don't know that there was anything that we needed to, I don't recall there being anything that we needed to set up on it.
It should be automatic.
Yeah.
Um, really. Let's see if we can. I think it will work, but let's give it a shot and see if we can connect to um, our gateway. We, it's not going to work, but we'll give it a shot. See. It's supposed to get an IP address, so yeah, that's not working. Um, let's just make sure. Yeah, it's not registering on the IoT server for some reason. And it really should provide a it really should provide a DHCP, which is really weird. I don't know why it's not doing that. Um, let's see. We could always try and do something like this. And yeah, it's not registering, unfortunately. It's pretty odd. I'm just going to see if I can.
Do you need a default gateway in there?
And in the sign, it should get that via DHCP.
Yeah, but if we've
Uh,
just set up the IP address via a static IP address,
yeah,
yeah,
but it shouldn't. I think it really should provide. It should provide everything via DHCP, which is why I would prefer that it did that. So
yeah.
just have a quick look and see if we can set that up. I'm going to power cycle this gateway if I can. Yeah, let's see where the power button is. You got to pick the exact power button where it doesn't matter. You know what? We'll just try this again. Let's just going to try one more time to delete the gateway and see if that does the trick. We'll just delete these two components. Try again. So network devices, wireless. home gateway, and we want the siren. Now we'll hook the home gateway up. Maybe if you do it in the reverse order, it prefers that. Let's see. Config, internet, 6.6.6.2. Let's see if we've got a wonderful. All right. I'm just going to share this just for the sake of completion to show you.
Is it now happy?
Yeah, of
Yeah.
course.
Of course.
There you
Yeah.
go. You can see you've got an
Sometimes it
IP
just
address.
wants another set of eyes to look at it. Yep.
I don't know. It's not worth trying to figure it out.
No.
But this is
Good.
this is what we've got. So we've got our IP address in the 192.168.25.100. So that is all working. And then let's go ahead and connect ourselves up to our server. So we'll see. Hopefully all the routing works correctly and we won't have any trouble. Yep, that looked pretty fast. So I'm going to guess that's worked. We'll go back and have a look at the server now, and we'll hopefully see that there is another IoT device there called Siren. We'll just change that name to Siren just in the network. So I'm going to go back and show you now the server. And let's have a quick look and see that there you go. There's the siren. There's the fire sensor. Okay, so we're all pretty much ready to go, right? So both of them are off, as you can see. And what we'll do is we will now go into the simulator that does the environmental simulation. So that's over here on the programming tab. You can see, so each device has that ability. So what we're going to do first is set up the conditions so that when we do that environmental simulator, our devices will react. Okay, so let's give it a shot. Let's say fire on. So if this is pretty straightforward, if the fire detected is true, then the action that we want to take is turn on the siren, and we'll save that, and then we'll have another one, fire off. So if the fire monitor goes back to false, then we want to turn off the siren. So there you go. So those are the conditions that we're looking to do. So fire detector turns on, siren goes off, fire detector turns off.
Siren goes
Then
off.
yeah, well, siren stops going off.
True.
Okay, so that's the idea. All right, so at this point, what we have left to do is really the environmental simulation. So let's give that a shot. So I'm going to go back to the network just for a moment, show you what I'm doing. So back over here, what we're going to do is we're going to drop in something that's called a thing. It really doesn't have a. It's under components here. It's just a thing. So drop that over here. It's this thing. We're going to call this on fire because we're simulating here some sort of object that has caught fire in the lab. So what we need to do then is to configure the thing so that it behaves like an object that's on fire. So this is where we start to get into the programmatic tab here, the programming tab. So first off, you can see you're basically creating your own IoT device. It can do anything.
Mm.
Um, it could connect to the network and stuff like that. But we're just going to model something that is just a piece of equipment that's just caught fire. So I'm going to delete all that other stuff. Start with a blank canvas, and here under main JS, you can see that there's a spot that you can do um, that you can create your own code. So just give that a nicer name just so that it's clear what we're doing. So we'll call this project fire empty JavaScript template. This is where things get started. So we're going to double click that. That allows us to edit this file. Okay. So I hope that JavaScript is familiar to everyone. If not, then it's pretty straightforward. You'll be able to read along. This is a very standard kind of way to set up a simulator when you're doing this kind of stuff. You got functions that the engine will call at different points in time. So that's the idea. It's a very simple scenario we need to do. Just a one-liner. Set device property. So this thing you can like create properties for it in JavaScript. So that's what we're doing right now. We're just setting that property that we saw before, which is IR or infrared. And you remember it said set it to 900 to simulated fire. And we saw that in the fire monitors documentation there. So that's all we're doing here. So let's go ahead and run that. So if we now go back to our network, what we're going to see, it's kind of funny. Um, so can you see the network there with our little thing that's on fire over here in the corner?
Yep. Can now, yes.
So you can see the siren is deactivated. Now, if I take this little thing and I bring it over here and I drop it right next to the fire monitor,
Oh, nice.
so that's the idea. So that's what it is. So the thing is, emitting infrared. The fire monitor picks it up. The siren goes off. So you can see that's the scenario that I'm modeling
Yep.
today. So if we take that now out of the lab, then you can see that the siren has gone off, and it just basically just reacts to hot stuff next to it. There you go.
That's cool.
Yeah. So any questions about any of that?
No, not from me. I think I need to refresh myself on JavaScript, but as you mentioned, it was only a very, very simple script. So
Yeah.
yeah.
Yeah,
Oh, that's cool.
JavaScript's not required for this unit, but it's if you want to play around with simulators, it's pretty easy. Just put into ChatGPT and
Yeah,
it'll handle your JavaScript for you. Uh, so the idea is basically you can make it do literally anything. It's an enormous array of different environmental parameters that are in there. Uh, they've really gone, I think, even perhaps further than what you might ever use. They have everything modeled in there from gases in the room through to uh, humidity and it always you can see things change over time and it's quite an involved simulator. So that's the idea, and you can play around with that and extend it as much as you like. What I wanted to do in the last few minutes that we have today is to just discuss the security implications of what we've built here at this point. So um, we have this arrangement, and because this is the last lab, I haven't mentioned anything about security as I was building the network in the hope that we might spend a couple of minutes just discussing where the holes are in terms of the security. So this is a completely insecure network. There's a lot of vulnerabilities, a lot of misconfigurations that should be improved. So um, I guess I'll turn it over to you, Rich, if you'd like to have a go at it and see where would you spot things that need to be fixed from a security perspective.
Oh, well, as you mentioned, there's a whole heap of things. We didn't do any security around the wireless connection between the siren and the home gateway was one of the things that stood out to me. But there's also no controls around traffic anywhere in the network. There are no firewalls. There's no network access controls. There's no real security on the Internet of Things. control station up there in the control room, the server that we're using to register with. Admin's just completely inadequate. Probably just password authentication would be by itself would be inadequate. So there's a whole heap of holes that you could poke in in the network. But as you mentioned, when it was being put together, it wasn't being put together from the point of view of let's make this secure. It was put together with let's make this thing work in about 40 minutes. Um, yeah, so that's the things that sort of immediately
Yeah.
spring to my mind. But I know that that's probably less than half of what you have in mind.
Oh, it's a very good answer there, Richard. Thanks for that. You covered the main points, really. You're right. Home gateway is completely insecure. There's no encryptions, no passwords, no authentication. So really, anyone can connect to that. The other thing you mentioned, no access controls. That's also true. We have the server is registered probably on it will probably respond to HTTP
Yep.
if we give it a go, and then everything is sort of like in the clear. And then you have, even if it's not HTTP, the password, as you mentioned, is inadequate. The other thing is that we didn't secure the network devices themselves, like routers would have default passwords, switches as well would have the default password. And there's no physical security in the control room as well. So we didn't really mention that. It's not really in the network domain, but you would consider that as well. Like how do you physically access this equipment? Um, and the other thing that sprung to mind for me was that there's actually no access controls to the equipment for the fire monitoring and the sirens. So they're just like the fire monitoring equipment's on the same subnet as the lab equipment, which is
Yep.
probably not a good idea because uh, you could potentially access from the fire monitor from the PC depending on what API it exposed, and you could well, the same thing with a siren, and potentially you could just set off like a fire alarm, which would be pretty bad because that would cause a lot of panic and that sort of thing. So, in that sort of scenario, you want to secure it so that not just anyone can set off alarms and cause mayhem in the building. Um,
The converse is also true. If you had that level of access, you could suppress alarms. So start a
yeah,
fire and not have the appropriate alarming and alerting happen.
well, that takes you to a whole nother level of that's really a criminal kind of
Yeah.
level. I mean, you'd have a very bad outcome there if that happened for real. But that's the thing, and that's the reason. It's very good that you mentioned that because, at the end of the day, when all of your doors are controlled by electronic locks that are connected to keys, I know on campus, like when you want to exit a lab, then you can do that without swiping out. But if you think about the idea that everything can be controlled by IoT, then if you're able to stop people from exiting the room, that could be very, very bad. And it doesn't even have to necessarily be from a criminal perspective either. I mean, sometimes people just make mistakes with configurations and stuff gets uh, deployed wrong and things like that. And so if if you've done that and you made a mistake, then there's not a whole lot that you can do if you've left the network completely open and malware can come in and cause a disruption or shut things down and cause a, a situation where you have a loss of availability. So if you look at the CIA triad,
Yeah.
availability is a big factor when it comes to IoT devices. So if you and that's before we even get to the malicious stuff. So that's so there's a lot of things that having an insecure network can have an impact with IoT devices, especially as you go to the smart city kind of things. Also, if we looked at the fire alarms scenario here, but of course, even if you looked at the original lab scenario here that also had a camera, um, you know, accessing camera images is a privacy issue there.
Mm.
So, potentially if that's available on the internet, and there's plenty of webcams that people don't configure properly that are accessible from the internet, and so if you can imagine at the level of a smart city, if you had the whole of the traffic monitoring network suddenly be accessible, publicly on the internet, then that's it. Not only it's a huge privacy issue because, you know, it's obvious that if you have access to hundreds of cameras all over the place, you can see a lot of things that are really in the domain of privacy, but you also have the situation where, it can interfere with law enforcement activities. If that's why police encrypt their communications now. It used to be that you could just listen into the police, for instance, or with a scanner. So it's all about providing the environment in which the service provider can provide the service securely without compromising its ability to do so on any of the CIA triad endpoints there. So great stuff. I appreciate that, and I think we'll stop here. And I just thank you again, Richard, for coming to our last lab for the semester, and thanks to everyone else who is following on the recording. So this will be the last time that we'll get to have a chat online here. So I wish everyone all the best with their future endeavors, and maybe we'll catch up again on another subject. If not, then maybe we'll see each other out in industry. And otherwise, I wish you all the best and success in everything that you do. Thank you very much.
No worries. Thanks, Fierce. Really appreciate the work that you've put in over the course of the semester. Your presentations have always been clear and very easy to follow, and also at the same time very comprehensive. And balancing those two aspects, I know from my own experience is difficult, but really appreciate the job you've done, man. It's been fantastic.
Well, thanks, Richard. I really appreciate that and your kind words. And good luck.
Cheers.
Thank you.